Hello colleagues, I'm Leslav Kobylyukh, a student of National University Lviv Polytechnic, and I'm happy to be here today to share my experience and insights with all of you. In my time here, I had the opportunity to explore my passion and interest, including information technologies, business analysis, and integration IPs in real-life programs. So one of my main interests in discovering new ability of information technology to support Ukrainian language, and I've been fortunate to have some exciting experience in this area. This has not only deepened my knowledge and understanding of speech-to-text technology, but it has also given me valuable skills and perspectives that I can apply to other areas of my life and work. So, in my presentation, I'll be sharing more about the experience and insight in the accuracy of speech-to-text a piece transcribing of the Ukrainian language, including some of the challenges I have faced and how I will overcome them. I hope that my experience will inspire and inform all of you. So let's move to the introduction part. Speech-to-text technology is becoming increasingly important in Ukraine as digital infrastructure expands, but accuracy in transcribing the Ukrainian language is critical for communication, education, and access to information, especially in the wake of a Russian invasion. This research aims to analyze the accuracy of various speech-to-text APIs in transcribing the Ukrainian language from voice to text. Using a diverse set of audio input data, we evaluate the API's accuracy in terms of word recognition and sentence-level transcription and compare their performance to manually transcribed text. This presentation provides a comprehensive overview of the latest development in the speech-to-text technology related to Ukrainian language transcription, the method used in the analysis, and the result in their implementation. So, speech-to-text technology has rapidly advanced in the recent years, making it easier to convert spoken language into written text. While this technology has been widely adopted for English and other commonly spoken languages, there has been less research into its accuracy for less commonly spoken languages such as Ukrainian. In this article, we analyze the accuracy of the several STT applications programming interface and transcribing the Ukrainian language. We evaluate their performance based on various factors such as a complexity of language, speaker's accent, and background noise. So, the goal of this research is to analyze the accuracy of different speech-to-text APIs in transcribing Ukrainian language from voice to text. To achieve this goal, we will be conducting a series of experiments using the variety of APIs and comparing their performance to manually transcribed text. Especially, we will be evaluating the accuracy of these APIs in terms of both word recognition and sentence-level transcription. So, the second part is analysis and similar works. Speech-to-text technology has been a subject of intensive research in recent years. There have been several studies examining the accuracy of different speech-to-text APIs in transcribing various languages. However, relatively few studies have focused especially on Ukrainian languages transcription, making this a valuable area for research. There are several studies that have explored the accuracy of speech-to-text technology. One such study was in 2019, where was analyzed the performance of STT APIs for the Greek language. They found that the accuracy of the APIs varied significantly depending on the complexity of the language and the quality of the audio input. Second study took part in 2020, where was evaluated the accuracy of STT system for the Bengali language. They found the performance of the system varied depending on factors such as speaker accent, background noise, and the presence of fillered words. Third study was discovered in 2021, where was analyzed the accuracy of STT APIs for the Basystiuk language. They found that the AP has relatively low accuracy, especially when dealing with a complex sentence and unfamiliar vocabulary. In comparison to these studies, the current article focuses especially on the accuracy of STT APIs for the Ukrainian language, like affirmation studies, It evaluates the performance of this API based on various factors such as language complexity and background noise. Overall, the analysis of similar work suggests that the accuracy of STT APIs can be vary significantly depending on the language and the quality of audio input. One study that did examine Ukrainian language transcription was conducted by a group of researchers at the National Technical University of Ukraine, Igor Sikorsky Kyiv Polytechnic Institute. In this study, researchers compared the accuracy of three different speech recognition systems in transcribing Ukrainian language. The study found that all three systems performed well, with an overall accuracy rate of 88 for the best performing system. However, the study also noted that the system tend to strangle these proper nouns and words that were not in the system vocabulary, suggesting that there is still room of improvement in Ukrainian language transcription technology. Our next part is methods and experiment. One method of recognizing of Ukrainian language is the use of neural networks which are trained large data set to recognize the classified text. For instance, recurrent natural networks can be used to analyze word sequences and make decisions based on context. Another method is used of a natural language processing, named NLP technique, which allows the analysis and understanding of linguistic structure. For example, methods of constructing syntaxes tree can be used to analyze sentences, structures, and relationships between words. Yet another method is the use of deep learning and machine translation, which allows the conversion of speech to text and vice versa. For example, translation models can be used which are trained on a large data set and capable of automatically conversation text from one language to another. In table 1, you can see the comparison of different speech recognition and transformation methods. So as you can see, some works well with the sequence of words, some works well with a complex sentence, and some works well with the high volume translation in different languages. The Ukrainian language is challenging to recognize due to its various dialects and linguistic specification. So therefore, developers face challenges in the creating program that can be effectively recognized. Also, let's review some techniques. So the first technique is transfer learning. Transfer learning is a machine learning technique that involves training a model on one task and then applying the model to a different but related task. In context of speech-to-text, transfer learning could be used to train model on a large corpus of spoken English languages and then fine-tune the model of smaller corpus of the spoken Ukrainian language. This approach had the potential to improve the accuracy of the transcription by leveraging the knowledge learned from the English language to better understand the Ukrainian language. Next one is speaker diarization. Speaker diarization is a process that involves identifying who is speaking in an audio recording. In the context of speech-to-text, speaker diarization could be used to separate multiple speakers in a recording and transcribe their speech separately. So this approach had the potential to improve the accuracy of the transcription by allowing the speech-to-text API to better model the unique characteristic of each speaker's speech. The third one is contextual information. So contextual information such as a topic of the conversation or the background of speakers can provide additional information to add the transcription of spoken language. In the context of speech-to-text, contextual information could be used to improve the accuracy of the transcription by providing additional context for the speech-to-text API. To better understand the spoken language, for example, if the conversation is about a specific topic, the speech-to-text API could be trained on a corpus of the text related to that topic to improve the understanding of the language used in the conversation. The next one is acoustic modeling. Acoustic modeling is a technique that involves training a model to map acoustic features of speech, such as frequency and amplitude, to the corresponding phonetic unit of the language. In the context of speech-to-text, acoustic modeling could be used to improve the accuracy of the transcription by providing a better understanding of the acoustic characteristic of the spoken language. The next one is language model adaptation. So it's about language model adaptation, which involves fine-tuning and pre-existing language model on a specific domain or dataset. In the context of speech-to-text language, model adaptation could be used to improve also the accuracy of the transcription by training the language model on a corpus of spoken Ukrainian language data, which can help the model better understand the language and its nuances. So this approach had the potential to improve the accuracy of the transcription by allowing the language model to better adapt to the specified characteristic of the spoken Ukrainian language. And the last one is pronunciation modeling. Pronunciation modeling is a technique that involves modeling the phonetic variety of speech, including the variation in the pronunciation of different speakers' accent and dialects. In the context of speech-to-text, pronunciation modeling could be used to improve the accuracy of the transcription by better modeling the different ways in which words and sounds can be pronounced. This approach had the potential to improvement also the accuracy of the transcription by allowing the speech-to-text piece to better account for the variations of the pronunciation of spoken Ukrainian language. Let's move on and speak about the method and experiment and resources. For experiment, we use a dataset of spoken Ukrainian language samples. It was collected from various sources such as public speeches, radio programs, and interviews. The dataset contains of 500 audio files, with each file being approximately 5 minutes in length. For a total of 2,500 minutes of audio data, the experiment aimed to compare the accuracy of different speech-to-text IP using precision, recall, and F1 score metric. Three widely used and established speech-to-text IP were chosen for the experiment. So the first one was Google Cloud Speech-to-Text, second was Amazon Transcribe, and Microsoft Azure Speech Service. Each IPs use different algorithms and techniques for speech recognition, providing a diverse set of tools for the analysis. To compare the accuracy of the IPs, each audio file was transcribed using all three IPs, and the resulting transcription were manually verified for accuracy. The manual verified transcription were used as the ground truth transcription for the experiment. In paper, we have simply Python code that is short example of how you can compare the accuracy of different speech-to-text IPs using precision, recall, and F1 score metrics. The experiment used the dataset of spoken Ukrainian language samples, so it's free in the internet. So let's move to our results. And based on precision, recall, F1 scores obtained from experiment, we can draw some conclusion about the accuracy of three speech-to-text IPs tested. So Google Cloud Speech-to-Text had the lowest accuracy with a precision, recall, and 1F score of 0.4. This means that only 40% of transcribed samples were correctly transcribed, and only 40% of the ground truth samples were correctly identified in the transcription. On the other hand, both Amazon Transcribe and Microsoft Azure Speech Services had the higher accuracy than Google's Cloud Speech-to-Text, with both achieving precision, recall, and F1 score of 0.8. This means that 80% of transcribed samples were correctly transcribed, and ground truth samples also were correctly identified in the transcriptions. So the table 2 showed the precision, recall, and 1F score for each of three speech-to-text IPs. The precision is a ratio of the correctly transcribed samples to the total numbers of transcribed samples. The recall is the ratio of the correctly transcribed samples to the total number of ground truth samples. And the F1 score is the harmonic mean of precision and recall. So, as shown in the table, Amazon Transcribed and Microsoft Azure Speech Services has significantly higher accuracy than Google Cloud Speech-to-Text, with both achieving a precision recall and a F1 score of 0.8. Figure 1 shows a comparison of the precision recall for each speech-to-text IP. The figure clearly showed the difference in accuracy between Google Cloud Speech-to-Text and the other two IPs. It also showed that Amazon Transcribe and Amazon Azure speech services have very similar accuracy with the almost identical precision, recall, and F1 score. So overall, the experiment demonstrates the importance of comparing the accuracy of different speech-to-text APIs when selecting one for a specific application. It also has worth noting that the accuracy of speech-to-text API is highly depending on the quality and characteristic of the audio data, as well as the language being transcribed. Therefore, it's important to carefully consider the requirements of the application and the characteristic of the audio data before selecting a speech-to-text API. So that's it. Let's move to a conclusion part. And based on the results of the experiment, it can be concluded that Amazon Transcribe and Microsoft Azure Speech Services are more accurate than Google Cloud speech-to-text in transcribing spoken Ukrainian language samples. The experiment also demonstrates the importance of comparing the accuracy of different speech-to-text API when selecting one for a specific application. It's important to carefully consider the requirements of application. The accuracy of speech-to-text API is highly dependent on the quality and characteristic of the audio data as well as the language being transcribed. However, precision and recall scores for Amazon Transcribe and Microsoft Azure Speech Service were significantly higher than those of Google Cloud Speech. The results of this experiment are consistent with the previous research that has shown the different speech-to-text API have different levels of accuracy. For example, a study conducted by Google in 2017 found that its speech-to-text API had the same word error rate. Another study conducted by University of California found that the accuracy of different speech-to-text API varied depending on the type of audio data being transcribed. So that's it. Thank you for being here today. Thank you for watching this presentation and good luck for all of you in the future results.